Here we are, the solution to this example. We kind of laid it out in the last video. In this example, we're going to just, do this, finish it up. And so we laid out the modules. One of the modules certainly was a RAM. Well, this is a 32 by 8. The issue in this thing is it has both data and address, and we're actually going to need to use both of those. But the first thing here is we have a counter that's used to generate the addresses to sequence through this thing, and then we have a mux that's going to decide between either one of these addresses or the other address, which we haven't got to yet. ADDR. This also has a write enable. I'll put a write enable here, and it actually has a data input, and it's clocked also. We'll put a little extra in there. This is 8-bit data. We're going to have to load this thing with 0 when we find the largest value. So this, once again, this is different from the other problems because it has the data, and we're going to have to use the write enable. So this is going to be a 5-bit value. And I'm going to have to be able to clear this counter, and I'm going to have to be able to count up on this thing. That's my up input, and I think that looks pretty good. So what I need to do is, when I go through this thing, I need to put these values in a register because I'm going to be comparing them. I need to clear that register to keep the algorithm generic. And certainly I need some type of comparator down here. So the comparator is going to be comparing the output of the previous value with the current value, which is this guy. So we'll put that in there. These are all 8-bit values. Fill those in here. And what I want to know is when this is going to be A is greater than B. There's my GT, and we'll have a GT there. That looks good. So this register is storage for the data, which is going to be the largest value I'm finding, which I'm going to clear the first time through. And the other piece of storage I have here is going to be a register, simple register, and this is going to be the output of this register is going to be the address of the largest value. And so what I need to do is occasionally load this thing. Yeah, I forgot a clock again. Okay, so this is a simple register here. This has, we'll just call it LD1, and I'm also going to be needing to load this other register here, LD2. So I got 2 registers that I need to load. It's clocked. I think that's looking pretty good. We need to put in a FSM. And so this FSM is going to be a little bit more complicated because we've got a whole bunch of outputs here. So there's done, write enable, select, what else? LD1, LD2, clear. What else do I need on this? Probably need an up on it, so I'll just put an up. Okay, so there, 1, 2, 3, 4, 5, 6, 7 control outputs. Wow, that's pretty amazing. Okay, so also I got to know when this stops. It's going to have an RCO in here. It's going to have a go signal, and lastly, it's going to have, this is a status signal, GT, and it is clocked. Okay. Wow, this is looks complicated, but I think we're going to be able to do this. We'll put in a couple more pieces of information here. These are all 5-bit, and I'm ready to do this thing. So remember, I'm going to have 3 states on this. Each state needs to handle all these status outputs. It needs to assign a value for all of them. Generally speaking, I'm actually not going to do it. I'm going to actually skip a few. You'll see why in a second. But generally speaking, every state needs to handle every output unless it's a don't care. So this one will actually have a don't care. Okay, so here we go. I'll say the wait state And what keeps me in this wait state, this is very much like the other problems we did. Where if the button's not being pressed, I'm not doing anything. The go signal's not there, I'm not doing anything. So I get a go signal. I'm going to go to, I'll just say, the look state, and so this is go. Okay, so I've made this into a Mealy machine once again. It works really nicely that way. So what I want to do here is, in this state, I have to handle all these outputs. I'm just going to go down this list, right enable, probably turn it off. Select, I'm not going to use it. It's a true don't care. I'm not going to even put it in there. The issue for this problem is that I'm not going to be loading anything. So what's load? I'm turning the two load signals off, so the select doesn't even care. Up, I'm turning it off. What else do I have there? Clear. So clear's handled up here. So that's 1, 2, 3, 4. Oh, done. Okay, I am done, so the done light is on. So let's see how many I got. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. I'm missing one. Let's figure out what I'm missing there. Oh, the select is a don't care. So I have all 7 signals there. I didn't put the select in because it's a don't care. So in this state, I'm going to be looking. And so the first thing I'm going to do here is, well, when I'm not writing anything, and certainly I'm not going to be clearing anything in this first state. What am I going to be doing is I am going to be counting up. So we're going down the list here. And the select is now important. It's not a don't care. It's actually selecting one of these addresses here. And so it needs to select this 0 address. So there's the 0. Okay, so what else do I need? LD1. What's LD1? Okay, so here we go. LD1 equals LD2 equals GT. Okay, so that's the money shot right there. So I'm not going to do anything unless essentially the current value is greater than the previous value. Now I cleared it the first time through. I'm reading the address or the value at address 0 in the RAM, and so it's going to be comparing 0 or the current value to 0 because I cleared this register. So that's going to work fine. So let's see when it finds the largest value, when it finds a value larger than the one I've stored, I'm going to load the address into this register, and I'm going to load the value into this register. Okay, so that's the key so far, and I'm thinking, so there's 1, 2, 3, 4, 5. Okay, done. Okay, I'm not done. I'm processing, so I need to turn the done signal off. Okay, looks good. Okay, and I'm going to continue doing that so long as the RCO is turned off. The RCO turns on. I'm going to come over to this last state, and this is I don't know. We'll call it clear. And what I'm going to do is, in this state, I am going to write a value to RAM. There's my write signals turned on. I'm just going to cheat and look at these other values here. Up, pretty much a don't care. Select is super important. Select now it's selecting this address to appear there. So select is turned off. The loads, not using them. I can turn those off, and I think that looks good. So let's say, oh, done. I need a done. Technically, I'm still processing, so I'm in done land, done not land, and that looks good right there. I got 1, 2, 3, 4, 5, 6. I covered all 7 of these status signals in the state, as I did in that state. I only did 5 here because clear is a mealy output, and select is a don't care. And so at that point, I'm unconditionally transferred back to the wait state, and I'm going to go ahead and call this problem done. I don't think it's going to have any issues. Many ways to do this thing. Certainly this is good enough. Not the world's easiest problem by all means, but it was a problem where essentially I had to write something to RAM, which is makes it different from the previous problems we've done. So, well, normally this would be like interactive in a classroom, and you could be asking questions along the way. By all means, if you got questions about any part of this, just write me and ask them.